In this video, let's look at odd and even functions. I'm going to start with an even function. A function is even when there is symmetry about the y-axis. And when you have a graph, it's very easy to see. See, this half is identical to the other half. There is symmetry about that line. Another way of checking whether it's even is if for every f of negative x, you have f of x. And what does that mean? If, for example, your input is -3, and this gives you 5 for y, the same way if you have 3, you're going to get the same output. Doesn't matter the value of x, the output is the same. Okay, moving on. Note that the even exponent is not what really makes the function even. And for example, if you look at this function below, x minus 2 to power 2, this is even. But if you look at this function, it's not even. It's not symmetric about the y-axis. So you cannot just look at the exponent and just say it's even. So that's an even function. You got to be careful about that. It's not all the time. Okay, now let's look at some examples here. If I have a table, how can I be able to tell whether this is an even function? So I look at this one to tell a function is even if if x minus y and negative x, y is on the table. So I'm going to look at this example here. So I have -6 and 69. So do I have 6 and 69? And look at that. So what I'm focused here is this: if the input is either positive or negative, the same number, the same integer, it has to be the same integer, I get the same output. And that's not the only case. If I look at this one, I have -429 and I have +4 and 29. The output is the same. And for the input, check one is positive, the other one is negative. And in the same way, I'm going to check this one here, -2 and 2, and they both produce 5. So this is an even function. Okay, so let's go to the next one. And what do we need to do with the other one? Given a point -6, 8 is on the graph of an even function with the domain of all else, what other point must be on the graph? And I know if I have -6, then I should have +6 and 8. That point is also going to be on the table because I'm looking at, again, if I go back here, I'm just looking at the x and -x and the same output. So the inputs have opposite signs, but the output is the same. Okay, now let's look at odd functions. And for an odd function, a function is odd if it has symmetry about the origin. So look at this function here, it's symmetric about the origin. Or another way of looking at it, if you rotate the graph 180 degrees, it looks the same. And another way is if I have negative f of x, then it's going to be the same as f negative x. And we are going to look at some examples. Okay, so let's look at example 1 here. And again, to remember, it's not the odd exponent that makes the function odd. There is more to it than that. You got to be very careful. For example, this one has an odd function exponent, but it's actually not an odd function. If you look at this graph, it doesn't have symmetry about the y-axis. So here, Let's look at some examples how to determine an odd function. So we start with a table. If xy is in the table, and then we must also have negative x, negative y. So let's look at some examples. So I have this one here. Do I have another one of with the same coordinates, opposite signs? Yes, I see it here. I have -2, -1, and I have 2, +2, 1, and I have -1, -2. So this here must be odd. Okay, now let's go to the next one. Given that 5, 7 is on the graph of an even function with a domain of all u values, what other point must be on the graph? And this point is going to be the opposite. So -5, -7. It's going to be on the graph. So that's going to be the answer. Okay, so here let's look at how we can be able to prove odd or even algebraically. I'll start by showing you a shortcut that you can use to tell whether it's odd or even. So here the degree is 4, or here, and I see, so degree is 4, and I see the other exponent is 2. 4 plus 2 is 6. Both are even. So I know this function is going to be even. I just need to prove it. And the way I prove it is by plugging in -x to see whether I'll get the same function, the same original function. So here I have f of -x is equals to -x to power 4, and this is 5 -x squared. When you square or you raise a negative to an even exponent, it doesn't change. So this is just going to be x to power 4, and this is going to be 5x squared, which is the same as the original. So what does that mean? This here is the same as f of x. So what I have shown here is that f of x, f of -x, is equals to f of x, which is the definition of an even function. So I know that function is even. So let's go to the next one, and let me start with a shortcut to show you whether it's even or odd. So this is 5, this is 3. Both are odd, so I know the function is odd. I just need to show it. And I'm just going to plug in -x. That's how I show it. So this is going to be f of -x is equals to -x raised to power 5 minus 3, and this is -x raised to power 3. If you raise a negative to a negative exponent to an odd power, it's still going to be negative. So this is going to be x to power 5, and this is going to be positive because it's a negative and a negative, 3x to power 3. And one thing you see here is that these signs are opposite of the original, so that shows me it's odd. Or specifically, if I factor out the negative, I'm going to get x raised to power 5 minus 3x cubed, which is the same as the original function, and I see this is the same as negative f of x. Okay, so this means I have shown that f -x is the same as f of -f of x, which is the definition of an odd function. So I know this one is odd. Okay, let's do another example here. Again, let me use the shortcut. And here I see there is a constant here. When I look at this equation, I see there is a constant. This is even, this is 5, which is a constant. But I also know that it's the same as x raised to 0. And 2 is even, 0 is even, just like 2, 4, 6, 8. So I know this is going to be even. I just need to show it. And same way, f minus x is equals to negative x squared plus 5, and this is going to be x squared plus 5. This is the same as the original function, so this is the same as f of x. So that means f of negative x is the same as f of x. So this is an even function. Okay, we do another one. So again, I start by using the shortcut. This is even, and here this is raised to exponent 1. So this is even, this is odd. So when I see a combination of these two, one exponent is even, the other one is odd, I know it's going to be negative. I just need to show it. So I'm going to plug in negative x. So this becomes negative x squared, and then minus, this is going to be 3 negative x, and then when I simplify, I get x squared plus 3x. And if you compare this one, this is different from the original. So both signs did not change, and this is not like the original function. So because both signs did not change, and this is not the same as the original, I know this is not even. So here, based on this, I can see that this is not even, because that doesn't look like original. Now let me check odd. Let me check odd. So I'm going to factor the negative out. So this is going to be x squared, and this is going to be negative 3x. And also, if I look at this one is not like the original. It's not like, so this doesn't look, if I factor out, this should be positive. This is not f of x. So I can say here, f negative x is not equal to negative f of x, because I see this is not the same. It's not the same, and I can also say that here this is not equal to, this is not equal to f of x. So this is going to be neither. Okay, and let's do one more. So this one here, I can use the shortcut. This is odd, this is even, this is x power 0, which is also even. So even and odd, I know it's going to be neither. I just have to show it. So I do f of negative x is equals to negative x raised to power 5 minus 3. This is negative x to power 4 plus 1. So this becomes negative x to power 5. And this is going to be 3. That's going to be negative x to power 4 plus 1. And this is not, so from here, because I see this is not like the original, so I know that's not even, because that's not the same as that. I just need to check, and I can note here not even. I just have to check odd now by factoring out the negative to see whether it's going to look like the original. So I factor the negative r. So when I factor the negative r, this becomes x to the power 5 plus x to the power 4, and this is going to be negative 1. And see, this here is not like the original. This is not the same as f of x. So I'm going to conclude here using notation. F of negative x is not the same as f of x, nor is it the same as negative f of x. So this here is later.